In this video, we are going to talk about the basic concept and definition of Maclaurin series. So this series is based on the Taylor series. So where is the Taylor series? So the Taylor series, we talked about that in the previous video. In this video, I copied the power series over to this page. So do you see that on the lower right hand corner, there is a red Taylor series. So what happened is when a is equals to 0, a is a number provided by the problem, you have a Maclaurin series, and this is called Maclaurin series, is named after a Scottish mathematician, Maclaurin. Alright, so a Maclaurin series is a special case of Taylor series, which is when a is equals to 0, a is a number provided by the problem. So basically you have to take the red Taylor series and then you plug in a equals to 0 to those two places. So do you see those blue arrows? You have to plug in a equals to 0 to those places. So let's take a look at the expansion. The first term is f of 0, and then the next term is when n is equals to 1, you have f prime. So the f prime is the first derivative, a is equals to 0, the denominator is 1 factorial, and then you have x minus 0 instead of x minus a, and then the next term you have n equals to 2 and then n equals to 3. So you can see that the n is the green number, right? So 2, 3, 4, 5. I wrote the first 5 terms for you. And then what about a equals to 0? So the a equals to 0, again for the derivative, the parenthesis is a equals to 0, and then the other one, you have x minus 0 raised to the second power, the third power, the fourth power, and the fifth power. I know that in the fourth power, I miss a 4 over there. All right, so this is how you do the expansion of a Maclaurin series. And then for the Maclaurin series, I have a few important Maclaurin series for you. They exist in almost all the textbooks. So these are some important Maclaurin series, and their radii of convergence are. So we already talked about the first one, 1 divided by 1 minus x. So this is a rational function that can be represented by a Maclaurin series. And then the Maclaurin series, you can look at the right hand side of the equation. And then the e to the x, we have a Maclaurin series for e to the x. We have a Maclaurin series for sine of x, cosine of x, inverse tangent, the ln1 plus x, and the x plus x raised to the kth power. So this one you can take a screenshot. I decided to type it up instead of write down, because I afraid that I might wrote a typo on here because there are too many symbols. So this one you can take this down. You can either copy that over to your notebook if you are using an iPad to take notes, or you write this down, you copy this, you handwrite this over to your notes. Also, if you open up any textbook, they should be in the section where they introduce power series and Maclaurin series. All right, so that is the end of this video. Make sure you write this down. Oh, before we close this video, now here is a what if question. Hey, what if I see a function that is not one of this? What if the function is not one of this? In the next video, I will show you how to build a series when the given function is not one of the function you see right here. All right, so this function, they already derived that for you. The book already derived that for you. You can use them. When you see this function on your homework or exam, you don't have to derive them again. But what happens if you see a function that is not one of this? Then you have to do some work to get the series. And I will show you how to do that in the next video. Alright, so now that is the end of this video. If you think my instruction is helpful, let me know in the comment section below. Like the video, subscribe to my channel, share the video for me. Appreciate your help. I will see you all in the next lesson. We are going to do some example regarding Taylor series and the Maclaurin series. I will see you all over there. Signing off for now.